Okay, here we go. For 2701, what we've done is instead of using 3 push buttons with the third being a jog push button, now we're using the 2-position selector switch to select between run and jog. And we're back to 2 push buttons, just a start and stop. And then we have our 3-position selector switch that is going to actually determine direction. So we're going to have to switch the functionality just a little bit for that. And then the only other added feature that we have in here is we want to keep track of run hours. Now previously we just had a run second timer, and we know that our run seconds are not going to be sufficient for a plant operated pump, because we can only count to a maximum of 32,767, which is going to be a little over 9 hours. So what we want to do is create a calculation for us to be able to convert to hours. Now I do have a video that just talks about calculating run hours, so check that out before you try to accomplish that in this particular shop job, just so you have an understanding of how we're accomplishing that. And I'm going to do that here in this solution video as well. Lights are going to be the same as they were for the last job. We have the automatic start function. So basically all we've changed is the methodology of how we're going to select run and jog, and then we've added in this run hour functionality. Okay, so let's switch over here, and I'm starting with 2601. First thing I'm going to do is save this as 2701. And we want to come here and change this to 2701. Okay, so in 2601, we also talked about this Composite Disabler, and the Composite Disabler is a way of not having to have these instructions repeated multiple times. We're going to go ahead and leave that there. I think that's going to be very useful. So here we are going to have a start, and we are going to have our a selector switch for forward. And then we are going to have our run command binary. That's all the same. Now we're not going to have a separate jog rung and function here, so we can go ahead and delete that. And in place of that, we are going to just have our 2-position selector switch in here. And this is going to be, we're going to have to rename this. We used it to reset a counter before. So now it is the mode switch, where the 1 equals run and 0 equals jog. Okay, and we call this mode. Okay, I believe that's what I called it here. Yeah, so I said mode, and A equals run, B equals jog. So position A is closed or 1, and position B is open or jog. Okay, and we're going to come back over here. So that's going to give us that jog functionality and not let us hold here. So when we do push start, we will energize this, but we won't be held in. Okay. And then for reverse, we're going to want this same, I already have focus on here, so if I hit Control C, and then I come down here and put my focus right there in the corner and hit Control V. For some reason I didn't want to do that. Okay, I have that same functionality there, and then I can delete this line right here. Okay, so then I believe in our forward and reverse, we could go ahead and get rid of these because we don't have those jog lines there, and it drastically simplifies that as well. Okay, so that should take care of the direction change, and then I believe down at our outputs as well. Yeah, we don't need this jog functionality here because it's built into the absence of a holding rung above. So we can get rid of that. Okay, so that switched us, everything we've done so far switched us from a 3 push button setup to 2 push buttons and a selector switch. Okay, so we've got that converted over to 2 push buttons and a selector switch for our run and jog functionality. Everything else should stay the same, and our auto start function should be in there. Our blinking lights based on direction and direction change, none of that should have changed, and so that is all good. So now all we need to do is, and we're going to have the failed timer on this one like we did on the previous one, so we'll leave that there. We have the motor timer for direction change. That's good. So now what we need to do is just keep track of run hours. So I'm going to put this down at the very bottom, okay? And we're going to kind of do this in stages. So number one, the run hours, we could care less about the direction. So if we are running in forward or we are running in reverse, either one, we want to keep track of run hours. So this is going to be my 7th one there. Okay, so those are my 2 status for whether I'm running in forward or reverse. Okay, and so then I want to do something with that. So I'm gonna start a timer, and I'm going to use an on delay timer here. And let's see what is available. So I'm going to come over here to my timers, and there is this button called usage, and if you click on that, it tells me that T40 and T41 are used. So we're going to need to go to T42 here, T4:2, come on, T4:2, okay, and this is going to be my run hour timer, okay, and I'm going to call this run hour timer, okay. And so right now I'm going to set up seconds, okay, and then we're going to look at the calculator here. And so we know that there are 60 seconds in a minute, and we also know that there are 60 minutes in an hour. So if we multiply those two together, that means that there are 3,600 seconds in an hour. So if I put a preset here of 3,600, that means every time this timer is done, I can increment the run hours by 1. Okay, so what I'm going to do here is add another rung, and I am going to say if this guy right here, it's not going to let me do that, T4:0, if it's done, okay, that means we've completed an hour. We've reached 3,600 seconds. And so I want to do something. Well, what I want to actually do is just add an hour to my run hour total. Okay, so let's come over here and let's look at our integer table, and let's look at usage, and nothing is used. Okay, so we're going to use N70 for our run hours. So what I want to do is come to our add function. So let me hit this little left arrow here and come to the Compute Math tab and click on Add. My focus down here. Okay, so I'm going to say N7:0. Okay, and it's going to ask me, hey, what is this? And this is going to be my motor run hours. Okay. Okay, so that's going to be my run hours. And every time this is done, I want to add 1 hour to the total that is stored in N70. And then I'm going to put that result back into N7:0. So it'll always have a total of how many hours that I have run. Okay. All right, so we're going to start with this and then we're going to improve this. Okay, so I'm going to go ahead and download this. Okay, so let's test out our functionality on our run and jog first. Okay, so we'll come up here and we're going to, I'm selected in forward. Oop, and I'm not holding. Oh, because I'm in my jog position. So let me put this up to run and then I should hold. Okay, so that's good. And it's letting me go in the same direction. Okay, so now I'm going to flip this and I'm going to try to go in the other direction, and it's going to give me my directional flash, which is good. And then it should automatically start in reverse, and I should be able to stop and start in reverse. Okay, so that's good. And then I should have a jog functionality in reverse, and that's good. I'll come back to run here. I'm going to try my overload. That's good. And now we're going to try our forward. Forward overload. Okay, that's excellent. And just for good measure, we'll try the E-stop. It works there. And we'll have to wait for our timer. And now we're going to try our E-stop. Okay. So all of our functionality, porting from 3 push buttons to 2 push buttons on a 2-position selector switch, came over properly. Okay, I have not changed the fail timer, the 4-second fail timer from the previous shop job. To test it, I would actually have to stop the video, unwire, test it, stop the video, rewire, because unfortunately I don't have the toggle switches like we do have in the shop. So we're going to trust that that is still working the same as it did in the previous job. We didn't change any of that code. Okay. So now what we want to test is our run hours. And we're also going to find that there's an inherent problem in the run hours. So that's all the way down here at the bottom. It's easy to find. Okay. So right now I am not running, so I'm not timing. Okay. So I start running in either direction. Doesn't make a difference. It's just total run hours on the motor. Okay. Now, one of the things that Allen Bradley allows us to do is we can actually come in here and change the accumulated value and speed things up a little bit. Excuse me, so we don't have to wait. And we're going to roll over, and I forgot to put in a reset function. Okay, so that's good. But anyway, this is a mess. Okay, so the problem is I should have made this a self-resetting timer, and I didn't. So what's happening is it's completed, it's set my done bit, and now it's every scan, it's adding that 1 in there. And then it got to my maximum, and we got an overflow, and it turned my motor off. Okay, let's fix that. So let's go offline here. Okay, this question that it's asking me here, remember I typed in a specific value there. It's asking me, hey, do you want to save that? No, I do not want to save that. Okay, so very, very easy. Our disablers go to the left, correct? So we want to put a disabler here. And as long, we want this timer to time as long as the timer is not done. So if I put T4:2/done, now that may seem a little odd that I am referring to myself here, but basically what's going to happen is the moment that this becomes done, that done bit will get set. We're going to come down here, and this done right here will increment our hour by 1. The next scan will come around, and this, because we're done, will lose logical continuity. It will self-reset our timer, and for 1 instant scan, the timer will not be running, even though we could still have a motor running. So it will reset itself because it lost run continuity, and our accumulated value will go to 0, and we'll start timing again all over for an hour. Okay, so let's go ahead and download that and test that functionality, and then we're going to point out a problem other than my self-induced problem. Okay. So we want to go to run mode here. Okay, I'm going to go ahead and start the motor. Okay, so the motor's running, and you can see the timer timing here. I'm going to go ahead and speed this up. Okay, so we're going to come. It is going to reach 3600, and when it did the math here. It added 1 hour in there, and then because it was done, it came around here. This lost logical continuity. We lost run continuity, and it self-reset. Okay, so that's how to do a self-resetting timer. You refer to yourself, the done bit of yourself here, and it'll just keep rolling over, resetting every time around. Okay, so let's trip this out a couple more times. Okay, so 3595. Okay. Okay, so we've got a couple hours banked there. Okay, so here's the problem with this solution. It appears to work properly. Okay, if I stop the motor, watch what happens to the accumulated value of my run hour timer. Okay. So you notice, I mean, I could get all the way to 3575. I could be extremely close to an hour, and then as soon as I stop the motor, I've lost that data about the motor. I've lost that 0.95 hours that I have in there. So there's a couple strategies that we can do to alleviate that. One would be to make this a retentive timer. And that means if I stop and then restart, I would retain the time. So let's go ahead and do that. I'm going to go comms, and I'm going to go offline. And again, it's asking me, do you want to save the numbers that I punched in there? And I say no. Okay. So now if I just click on the TON, and I right-click and say change the type, and it's RTO, retentive timer on. Okay. If I change that to a retentive timer, it will not lose that accumulated value at the end of, if I stop part of the way in between. The only problem is I can't self-reset myself anymore. Okay, so I'm going to have to come up with a different strategy. So here, when I'm done, the only time that I really care about done is the very next rung. So I'm going to come down here, and I'm going to add a new rung in here. Go ahead and maximize this. And I after I've added that in there, I just want to reset. So I could be fancy and actually do it on this same rung, but I prefer to do it on just another rung. So we have a reset instruction, and this is going to be T4:2. Be very careful that you're not resetting T40 or T41. Those are different timer registers. We want to just reset the run hour timer, and it's going to be based on the timer being done. Okay. So if the timer is done, then it's going to reset itself. So that done bit is only going to be on for as long as this rung has to run, and then after that it's going to reset. Okay, so let's run this. We actually need to get rid of this one. We don't want a self-resetting timer anymore. Okay, so now let's download this, and we're going to see the benefit of doing that, and we still are going to have a pitfall there. Okay, so we're going to go ahead and start. And I have my time incrementing there. And then if I stop, notice my accumulated value stays there. Okay. And then I start running again. And of course, it's going to accumulate for a certain amount of time. And then I'm going to stop again. And that gets us around the stopping and starting and losing some data. Okay, so that's a good means for a retentive timer. Okay, so I'm going to go ahead and hit stop here. Now let's look down here. So we currently are not showing any run hours because I downloaded, and when I download it, it goes back to 0. So I'm going to come here and I'm going to hit 35.95. Okay, so we're going to watch it roll over here, and it's only going to take 5 seconds, and we're going to see that this is going to increment and it's going to reset the timer. Now this is going to be on for only a blip of a second, so we're not actually going to see the logical continuity come and go, but you'll be able to see the effects of it coming and going. So I'm going to hit start one more time, and then 2, 3, 4, 5. And so you saw that we incremented to 1, and we only did it once. We didn't run away like we did before because we reset our timer. And now we're timing again for the amount of time that we're running. And I go ahead and hit stop. Now this is actually a pretty good solution. If we only care about run hours as they are whole hours, this is fine. But we might want to actually show fractions of an hour. And to do that, we cannot use an integer anymore, because remember, an integer is a whole number. It doesn't have any fractional component. So we're going to actually implement a way to show fractions of hours to give us a little more specific of a number for run hours. Okay, so if I go to offline here, and no, I don't want to save any of that data that I punched in there. Okay, so I was using integers here. Now I want to use some sort of fractional component. So if I come here to float, now we talked about integers before, but a float it's short for a floating point number, and a floating point number literally means the decimal point can move around in the number. It can float from left to right. If you remember when we were talking about scientific and engineering notation, we were moving the decimal point left and right. That's what a floating point number is. Okay, so we're going to use a floating point number instead of an integer here. This add function can do either. So I'm going to come here, and I'm just going to pick this first F80, and I'm going to drag it over here. And I'm also going to want to put it down here as well. Okay, and since we want to do fractional components, we don't want to do hours anymore. But we have this time base, and we can change the time base here to hundredths of hours. We don't have to change our preset. Basically, what this is what is going to happen is every 3,600 hundredths, or in other words, every 36 seconds, we are going to add 1/100th of an hour to our run hour total. So all we have to do here is change our source B to a 0.01. Okay. Basically, this source B should always match whatever our time base was. So before, our time base was 1 second, so our source B was 1. Now, our time base is 100th of a second, so our source B is going to be 100th is what we're going to add in there. Okay, let's go ahead and download this. Comms download. Okay. And so now I'm going to go ahead and start the motor. And you're going to notice my timer is a lot faster. Every 36 seconds it is going to complete. And you see that once we reach 3,600, we finished, we completed, and when we completed, we set, for a retentive timer on, we set the done bit. That done bit then added that 100th of an hour in there, and now we have a more accurate representation of run hours that we have. So if you put this on an operator display, you could see that you had 100.25 hours. And if the customer or the production facility that you work at needs that kind of accuracy, that is available. So that is a way to implement run hours in fractional components. I hope that helps, and we'll see you in the next video.